Okay, my name is Elijah Pamo. I go for African Community Education, or short known as ACE. And Zero Robotics is basically where kids control a robot in space, which is controlled by MIT and NASA. And basically, our entire concept is to compete with each other and who has necessarily the best code to pick up most of the debris that's being taken in space. And most of these debris is all around our atmosphere, and we control the robot to take these debris and discard them so we can have a cleaner atmosphere, a cleaner Earth. Yeah, so the program is basically just all about calculating the distance formula, where our robot is, and how we can get from point A to point B. The midpoint is point A and point B. Point A is where the robot is, and point B is how far the robot's moving. The midpoint is where we want in order to get the debris, so the robot can go to that midpoint, pick up the robot, and discard it. Taking it outside of the playing field to get points. Okay. And right over here, we have 348 as a score. And at the bottom, the game has ended.
The station is about the size of an American football field. It's located just outside the Earth's atmosphere. This is called low Earth orbit. It's not very high up, considering that some satellites orbit way out here. The ISS only takes about 92 minutes to orbit the Earth. That's about 28,000 kilometers per hour.
Together, these teams bring a wealth of talent and enthusiasm to the Zero Robotics competition.
That was an amazing introduction from Tracy for Alliance 3. And it looks like they are prepping the Astrobee to run that code real soon.
Alliance 3.
Yeah. Let's hear a round of applause for the conclusion of Alliance 2 code and the gesture ignition and Alliance 3's code. That's exciting. It looks like the Astrobee is getting there. It really is something to see the Astrobee having those little eyes.
So cute, isn't it?
Yeah, it is kind of cute, honestly. It's a little interactive too, and a nice flashing light. It's a responsive, it's a robot, but it has a reactive feel to it. Responsive.
I was going off to Object 0, and Alliance 3 is going to run in a bit. One thing I realized about Alliance 3 is that they actually go to the closest pickup points to the Astrobee and drop off basically the closest points to the edge within the pickup point. So, it's not a bad strategy, but I think it can be better. Alright, now it's moving.
Strategy, of course.
As indeed.
And every strategy we had submitted was wonderful. Here we go, it's proceeding. We're moving to the next object. Yeah.
Closest point to the Astrobee. Taking it
There
out.
we go.
And then you're gonna see it go directly to the left.
Yep, there we go. It's now dropped it off. Right outside the image field. Very ideal. Efficient movement. Great work.
Comes on object 5. It's gonna be dropping down a bit.
There we go. A second now. Now to succeeding on, carrying on with the path that their lives so amazingly coded for. This code is running live. We're in space right now. It's crazy to think about. This is so far away. So much amazing work has been done on the space station.
Object 1. So again, it's running in a counterclockwise movement. Just finished picking up object 1, going on object 4, which is where it's going to pick up from the bottom of object 4, taking it off to the right, 0, right, back home. So again, wonderful conclusion to the code and the algorithm developed by this team.